All the sensors that are sending a signal are going to have a ground fed to them from the computer, and it's got to get that ground from somewhere. Most of the computers will have like 2 powers going to it and 5 or 6 grounds, because it doesn't, it actually uses different grounds for different jobs. The one that we've got on the that we wired up on the table that day actually has got a whole wad of grounds that we had to hook to it. You remember that, like 5 or 6 of them? The voltage value from a sensor to the PCM, even if it's off a small amount and causes drivability problem, may still be within the normal operating parameters for a sensor and not set a code. Okay, now it's a brief story time. Donnie gets this van. It's like a 90 model Ford van, and when you crank it up, it runs really rich. Fuel pressure's checked, everything's fine there, and he's checking this, that, and the other, and he's running engine, key on engine off and running tests, and it's not really, hadn't really set a code anywhere, but it's running rich. And he says, I don't have any kind of data stream on this one, and so I can't really look in there, and the van's kind of where it's hard to get to the sensors and all. And so I pulled this is the OBD1, I pulled the connector up, and I saw the 2 wires coming to the connector for a data stream. I said, you have data stream on this one? He goes, no way. He said, the scan tool won't let me have data stream on this one. And I says, well, you got to tell it it's got an E4OD transmission, because those are the ones that had data stream. He said, well, this one don't have that. I said, that doesn't matter. Lie to it. Just tell the tool that's what you got, and it'll let you have data stream. And you got data stream on this thing. So he backed out, went back in, told him it had E4OD, and bam, he had data stream. He goes, I've been working on this thing for 4 days. What's up with that? So anyway, when we looked, the throttle position sensor is supposed to, when you turn on the key, the engine controller is going to peg wherever that throttle position sensor is as base idle. Which usually, in your Ford book, it says 0.5 to 1.5. I don't really like that. I want to see it be real close to 1 volt. I mean, real close to 1 volt. It doesn't need to.
Throttle?
Huh? Closed throttle. Now, the GM, it's going to be half a volt.
Why you want it at 1 volt?
Because it's 1 to 4.6. That's typically what works good for a Ford. And that's where this one generally is. I mean, I just had seen so many of them. Fords usually are about 1 volt. 0.8 of a volt to 1 volt, something like that. And then if you go up with it while you're watching that voltage, it ought to go up real smooth.
Yeah.
Now, if you go up and it's dropping out and it's acting stupid, All right, so Donnie, what he had on that particular van, was this thing would start out reading, more or less 1 volt, but when he started it, the vibration of the engine and all, that sensor was just about wore out, and that voltage, if you were to plot it on a graph, would drift up and down all over the place when it was supposed to be nice and flat. And as it was drifting up and down, the engine controller thought you were doing this with the gas. And as it did that, it was putting extra injector squirts in there, buzz, 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 and that was making it run rich. And it was as simple as a throttle position sensor. But here's the thing. The throttle position sensor is supposed to read, let's say it's 1 volt to 4.6, more or less. What your monitor is looking for is for it to go outside of here. If it goes, too low or too high outside of this range, it's going to throw you a code for too high or too low. In his particular case, it was just doing this inside the range.
Well, hey, don't it like wide open throttle, don't it? Like, basically don't even look at the TPS anymore?
It looks at the TPS all the time. It won't look at the oxygen sensor, and it don't use EGR. But anyway, all right, so what we have here, this is known as an in-range failure. Everybody needs to burn that in. If it doesn't, and like mass airflow sensors will do that. You'll see a mass airflow sensor sometimes. We had one on an Aztec that was similar to that Rendezvous, and when you drove it down the road, this thing, you didn't have any more than 50 miles an hour. That is all you had. Well, whenever your mass airflow and the throttle position is supposed to mirror each other. I showed that to Mr. Stokes there yesterday. It's supposed to go up and down, and together. In other words, if I get 2 markers and the mass airflow and the throttle position is supposed to track together, while we would go past about half throttle, the mass airflow would level out at about 2.5 volts, and it was supposed to go on up. Well, the computer says, well, if all they've got is 2.5 volts of air, that's all the fuel I'm going to give them. And so I says, me and a bunch of students were driving it, and we were looking at the scan tool, and I said, look, this thing is like it's got a governor on it, and it won't go over 50 miles an hour. And that might not be a bad thing if you got a wayward child that likes to drive crazy, you know. But anyway, we took that thing and pulled in over there, and I unplugged the mass airflow sensor. That way, it starts watching other things like TP and MAP and whatnot, just to determine without the benefit of the mass airflow, because it knows it can't trust it anymore. And this thing ran like a race car with a mass airflow unplugged. But it was an in-range failure. Did it throw a code for the mass airflow? No, it did not. You get where I'm going with that? The computer, if it's within the range that it expects, it has no clue. Now, sometimes the computer will do what's called a rationality check, and it will see that the throttle has gone pretty deep, or maybe it'll see that it's open in the idle air control and the mass airflow is not responding to that. It'll tell you that there's a correlation problem between those two. It knows if I open this should go up. I've opened that didn't go up, and it'll throw you a performance fault or something like that. And it does that with transmission stuff and all that too. But one way or another, that's another story. So I wanted to make sure everybody understood that. So number 2, everybody got the number 2. Number 2 true?
Yeah.
All right, number 2 is true. All right. Hold on, I lost my place here. Got to open up this other file. And here we go. All right, number 4.
3.
Well, 3, excuse me. I was jumping over the question, which I do all the time. Flash codes, which displayed on the malfunction indicator light, were used in early computer systems to retrieve diagnostic trouble codes.
Yes.
The early system was developed by all manufacturers and used a common method to begin the flash code display. That's wrong. On a Chrysler, you switched the key on 3 times, right? On the Ford, you had to ground the self-test input circuit under the hood. On a GM, you had to jump 2 terminals together under the dash. And they had a little connector under the dash that is different from today's DLC. Except on 95 Camaros, it had an OBD2 connector, but it had an OBD1 system on it, which was totally bogus. You know, but anyway, everybody had different. Some of the Japanese cars, the engine controller was under the seat. And you had to reach into a hole in the side of the engine controller and turn a screwdriver, and then it would flash out little green lights on the side, in the dadgum box there. And you had to be standing on your head looking under the seat, looking for these lights to flash. I mean, that's just, everybody did it a different way, you know what I'm saying? One day, and this is another funny story, the people at Bondi's over in the body shop were they'd have every time you have a crash, the airbag deploys, there's a little circuit that's got to be reset in the airbag module even after you fixed everything so that you clear out. I think it was like a B1919 on the cars you had to clear out with a scan tool. But on the Nissans that they happened to be working on over here in our body shop at Bondi's, they would have to reset that light because it would stay on even though everything else was fine. And the Nissan dealer, who actually was a store that belonged to us, was charging the body shop 2 hours to take care of that, to reset that. And so they says, do you suppose you could look and figure out what you have to do to reset that? So, because we're paying 2 hours every time, and it's tearing us up. And so I went and I said, well, a Mercury Villager is the same thing as a Nissan Quest. Let's see what you got to do on those. So I looked it up, and on that particular year model in that area that they were talking about, all you have to do is open the door and hit the door jamb switch 7 times, and it resets it.
And they're charging 2 hours to do that.
Yeah. I thought that was pretty funny, but they didn't send any more nowhere after that. But but anyway, and that was our store. It's like he's taking money out of one pocket and putting it in the other. He's charging his, All right, now then, let's go on down here to number 4. Most diagnostic charts and trouble trees cannot be used to locate intermittent faults. That is true. If you're going through a diagnostic trouble tree, you're going to be looking for something that's wrong right now. And when I went to Ford School in 1986 on this computer command control, the electronic engine control stuff for Ford, I came back I'd already been doing a little bit of this at dealership, and I went to the school on it, and I came back after that week-long school ready to change the world. They had this big old thick book called the H Manual, and it would have you to go through these little trouble matrices, and after I fought with that thing for about a week and I was having no luck at all fixing anything, that old H manual wasn't very good, I folded that thing up and I put it on the shelf and I started measuring voltages and looking for signals and seeing what they look like. And I got to where I understood that a lot better, because it's not, you know, the trouble tree is not teaching you anything. Now, sometimes it's a good idea to read the trouble tree and figure out what they're trying to get you to do. But if you have to depend on a, you know, if this is right, do this. If that, you know what, you don't really know what you're doing. And sometimes you get to the bottom, it still ain't fixed. And then you're out of ideas. You know what I'm saying? You need to be able to think critically about that kind of thing. The trouble tree sounds good, but all right. Number 5. In light of the total number of vehicles being produced that use computer control systems, most customer complaints are actually the fault of the computer. That is false. People, I wish, and this is this, if I was somebody that was a believer in big windfalls, if I could figure out a way that I could collect 50 cents off of every electronic box that had been replaced that wasn't bad, I could probably retire and buy a casino or something. You know what I'm saying? Because this is a huge amount of money. Now, you can actually do everything that you know how to do and eliminate everything else. And sometimes your shop manual will say, substitute a known good part. That's just fine if you have one. You know what I mean? Now, Sean and I, on that car the other day, we checked for powers and grounds going into that computer, and we actually did the stuff the computer wants to do and watched it raise the car up on that air suspension computer. And when we determined that it had everything it needed, the scan tool was reading wrong, and we could make the other stuff happen by triggering the relay and the air springs, and we decided the computer's got to be bad. And when we put it on there, everything, you put it on there, Chelsea put it on there, and it worked real good. So that's how you do that. If it's got powers and grounds, but it ain't doing its job, and all the inputs are like they're supposed to be, you know, you got computer issues. But most of the time, people want to do that because they know how to change the computer, right? I don't know how many of them that I saw that had been smacked, people have been smacked around on these old 60 pins like what the Broncos got in it. They'd bring it in there and they were just throwing up their hands, you know, didn't know what to do. And they said, this thing's been to this shop, and this one, and this one, and this one. And I would pull it out and pull the connector loose, and those little round female terminals in there were split on one side. And I would take I'd pull the little red wedge out, and I'd take my little sharp pick, and I'd tweak those where they'd be tight again, and plug it back in. And I don't know how many of them suckers I fixed by tightening those pins up, because the pins loose, rattling around, you're not getting a good signal, all that kind of stuff. Number 6 is, although you should always check manufacturer specs, most pickup coils found in magnetic pulse generators have 2,000 to 5,000 ohms of resistance. That's false. You can't go by that. Number 7, a diode that has low resistance in both directions when using an ohm meter is open. That's false too. Open means it's, you know, like cut. Yeah. Do you guys know the difference between an open and a short? A short is whenever you got a wire touching ground or two wires touching each other. An open is when a wire has been cut or there's a connector disconnected. Every time something winks and blinks and it's not working right part of the time, everybody won't say it's got a short in it. You know, and you need to understand what a short is and what an open is. It's two different things. Number 7. 8, excuse me, some input sensors produce a very low voltage signal, less than 1 volt, and the signal must be amplified before it's sent to the microprocessor. Well, yeah, that's supposed to be true according to these people, but usually a microprocessor has an amplifier inside of it. You know what I'm saying? It can do that. So, but I will tell you that, and this is something that's pretty important for me to say, you can have really good, clean crimps. Like, let's say, on some of these vehicles that would be throwing a mass airflow sensor code, or the throttle position sensor would be, the voltage would be drifting just a little bit, enough to where, you remember I told you when you switch on the key, it looks at whatever it sees as its benchmark baseline voltage. And if it drifts above that a little bit and stays there even though you've let off the gas, it calls that part throttle. Well, what does that do? That causes the idle to stay up and do stupid stuff like that. And so somebody's already put a TP sensor on it, and just like it was, that's what they say. So what we did there, you unplug, you make sure you remember which wire goes where, leave your little rubber seal on it. Listen to this, it's important. You'll do this with probably the end of the week. You unplug them little suckers and you pull them up, and those little crimps where that wires are crimped around that copper look so beautiful and so shiny and so pretty. You'd never think there was a problem there. But there's such a tiny little whisper of current going through those wires, it doesn't take much. They're not going to get hot and burn the wire up like it would on that headlight. Who was working with me? That was Zach. It was working with me the other day on that. We had a headlight bulb on that Ms. McGoolby's car. We replaced the bulb, plugged it in, still didn't work. You unplug it, look at the connector, it's cooked. So we had to put another connector on there, right? That's because the current's flowing. On a sensor, they know current flowing, very, very, very tiny amount, maybe. But what we did on that one was we put your connectors, put your wires up, and I got pictures of that somewhere that I took. Put your wires up so that your connectors are up here, right? All right, and you got your, you know how it's crimped around the wires right here? And then you got your insulation down there. All three of these wires are sticking up here because you pull them out. You got to keep them in order. You got to put them back the same way. All right here where it's crimped around this copper and all that, you're going to take your soldering iron and you're going to solder that real neatly without a big blob because you want it to go back into your connector shell. When you solder that and put it back in a lot of cases, all those problems will go away. What did it cost to do that? What did it cost you to do it? If it fixes it, you can legitimately charge a customer because they pay you for what you know as much as they pay you for what you do. You know, knowing what to do and then doing the work is what you get paid for. Now, when you don't know what to do and you do the work and it's still not fixed, you sometimes get paid for that. The people that own that Rendezvous paid some yo-yo $130 to put spark plugs in it to fix this stuff that we fix. $130 change out that spark plug that didn't fix it that good.
Low fuel pressure on a bad battery.
Yeah, and it was bad battery. The battery was really stupid and weak and would just go dead all at once, and then it would start and die and start and die. It's just, you know, that battery's got to be, you know, good and strong on these newer cars. All these electronic boxes are programmed to look and make sure their voltage is where they're supposed to be. If they see the voltage going up and down or below a certain level, they're going to do all kind of weird stuff. And I mean, my rationale was let's just get a good battery like what goes in that thing and put it in there and see what it does. It hasn't failed to start since then, but it was start and die, throw codes, up and down voltage and all that before. Number 8. Wait a minute. Number 8 is true. Number 9, volatile random access memory. Okay, that's these tickets. Okay. Do we have to
re-sign these?
Hey, no, we don't. I mean, if they've already been signed, then no big deal.
Okay.
Yeah, we'll take it. All right. Let me see here. Let's see. Volatile RAM, which is random access memory, will lose its data when the ignition switch is turned to the off position. How many of you guys understand what RAM is in a computer? Okay. What does the RAM do? What's the purpose of it?
Like, I know if you're playing like high-speed games and stuff, you got to have a certain amount of RAM to play it. That's just so it'll go faster.
Okay. Well, if you were gonna explain it, let's say that you were trying to explain it to somebody that actually didn't understand anything about it. You got to put it in words they can understand.
Capacity of data that can be played at one time.
Huh?
It's like memory cabinet.
Well, yeah, it is memory, but this is what it is. Think of your RAM as your workbench. Okay? Now, let me ask you this. You said you had to have a lot of RAM to play the big game?
Like World of Warcraft.
Yeah, all that stuff, because you got a lot that's got to be done there.
Yeah.
All right, try doing a lot of heavy-duty work with a little bitty workbench. You ain't got room. Your stuff's falling off and all this kind of stuff. You're filling it up. See, on the what RAM does in a computer, when you boot your computer up, where does the operating system go? On the RAM. Yeah, the RAM for the you're operating out of RAM because it's so much faster than that silly hard drive. Now, you got solid-state hard drives nowadays that are faster, you know. But the fact is, the operating system and every program you run is loaded into the RAM. And so on your cards, the random access memory is actually where a lot of stuff is stored. Whatever it's working with is stored in the RAM. See, your car computer's got an operating system. It's just that its inputs and outputs are different. It doesn't have a keyboard and a mouse and a monitor, but it's got other things. The inputs are from the sensors, the outputs are the fuel injectors, and, you know, whatever you decide to do with your feet and all that kind of stuff. All right, now, number 9. It is erased. RAM is erased. Now, we talked the other day about non-volatile memory. You remember the speedometer, the miles in your speedometer? That's non-volatile. You're not going to take a battery cable off and have a car with no miles on it anymore. Ain't happening. They're not going to set it up that way. Computer lookup tables will record changing inputs of a running vehicle for easy retrieval by the computer's processing unit. Wrong. That's not the way that works. Read the chapter, okay? Good deal. Number 11. The most important check to be made before diagnosing a PCM-controlled system is a visual inspection. What should be checked during the visual inspection?
Battery voltage.
Vacuum hoses. Well, battery voltage is not a bad thing to check. I don't know if you can see that visually. You're probably going to have to hook something up. They're talking about what you're actually looking at with your hand. Now, Chelsea, you had this expedition that you put that neck of that throttle body back on out there a while ago, and it was running really bad, right, when we got to put it back on. And within a few minutes, Chelsea had it singing. It's a nice little smooth tune. And what did you have to do in order to make that happen?
Hook everything back up, right?
She had to do a visual inspection and find the vacuum hoses that she forgot to hook up. That's what it was, and she took care of it. In the binary number system used by computers, each bit of information will either be
5 to 10.
which one?
I'm over 5.
Come on, 1 or 0.
Oh, no, 5
That's
or 0.
A. Remember, I told you about binary math the other day. It's always going to be a 1. That's why they call it binary. Bi means 2. There's only 2 values in each bit, right? Also, let me say this. When you're talking about computers and networks and all this kind of thing, all right, now, if I've got my little network here, it says right here on my local area connection, look at this. Watch this now. It says 100.0 Mbps. What does that mean?
Think about it for a second.
No. What? He's close.
Millibyte.
You just multiplied it by a factor of 8.
Is it milli?
It's megabits
Megabits.
per second, not megabytes per second. Yeah. Now there are 16-digit, binary code things too, but 8. Most of them are like 8. All right. So there you go. Just remember this: megabits, not megabytes. All right. You're used to saying megabytes because of the storage and all that, but data transfer is megabits. Okay. Number 13.
No biggie.
For a computer to receive information from the sensor, it gives commands to actuators and requires
C.
what?
Interface. I don't know.
That's an interface. It's got to be able to talk back and forth, right? Electromagnetic interface can be suppressed on a vehicle by doing what? No, not interface, excuse me. Interference. Duh. I don't know why I read that wrong. EMI can be suppressed on a vehicle by what? D. Shielding the conductor with metal. And what do we mean by that? We take our wires, and to begin with, we talked about that the other day, we're going to wrap them around each other, and then we're going to wrap them with foil, a foil tape, and then we're going to ground that foil tape, and that keeps that. You know what we used to do when we'd have some radios, when I was at Ford Place, we'd have radios that had noises coming in from here, there, and yonder. We would get a piece of foil, and we would hold it around the wire harness and move it up the wire harness going to the radio, and the minute we come to a place where it would stop making that noise, and we put that foil around the harness and put it in play. I mean, as a shield is what it was. It turns back that thing.
Did they help your reception too?
Yeah, well, not the reception, but it would stop this scratchy static noise. That's what we were after. Okay. 15. Which of the following semiconductors are constructed by joining a piece of P material with one piece of N material? That's number 5. That's a diode. When a computer detects a malfunction, what is set to indicate a portion of the system at fault? I mean, what do you pull whenever you plug it in? What's the first thing you do? You're going to see what the codes are, right? Diagnostic trouble codes, right? Number 17. Applied voltage measured at all computer battery and ignition feed terminals with PCM with the ignition switch turned on should be within what percent, or how much of 0.5 volts of battery voltage. If it's much lower. Now remember, Sean, the other day we were seeing 0.8 volts on that computer. On the scan tool it showed 0.86 volts, but when we checked it physically it was right at battery voltage. That's one of the reasons we knew that computer was bad, because it was seeing something that wasn't true. 18, the breakout box. You know what a breakout box is? The breakout box actually plugs in between the wire harness that plugs into the computer, and it's got a panel with a bunch of neat little holes in it that are numbered, so you can check stuff real easy. We got one of those we use on that Ranger and on the Fords and stuff. Also, there's a I've mentioned this before, and I got one of these. There's a breakout box for your DLC. Plug it into the DLC. You can still plug your scan tool in, but now you've got these little test ports where you can hook your scope up and see if you got data transmission. See? It's got little places, a little banana plug thing, and I can show you that. Number 20. Number 19. The computer contains a crystal oscillator. What is that?
I don't know.
It's a clock. Come on, give me a break. You know what a clock is? A crystal oscillator. You know the little things that you see in a computer, Wes? It looks like a little oval-shaped can, like that. I mean, it's sort of like it's a silver thing. It kind of looks like a little oblong-shaped can. It's sort of, if you look at it directly from the top, it looks like this. It looks like a Spam can. Almost, it's a little bitty thing. That's a crystal oscillator. It's a clock. All right. Number 20, the blank is constructed of thousands of transistors that are placed on a small chip.
Computer.
That's the CPU.
The actual processor itself, or
Yeah, the actual chip. I mean, like your CPU would be in your computer. You know, like your AM3, yellow square processor and all that.
Bunch of little pegs on the bottom of it.
And I'll tell you something else you probably don't know. You know these little units where you see a little square chip that's got a whole bunch of little legs on all four sides of it?
yeah.
Did you know that all four of those legs are soldered together? That's not all. That's got four connections to it, not all the ones that you think. I mean, see what I'm saying? Isn't that crazy? I mean, you're thinking it's got that one little chip has got lots and lots of stuff coming out of it. Just get those four. As a matter of, I learned that when I was up there at that Jeep hybrid school. I mean, not at Jeep hybrid, not Jeep hybrid school, but that hybrid school. Joey Henry, that guy from Russell, Kansas, told me about it. No, he ain't bald headed. He's got hair, and he's younger. He's younger than I am. So, so clues. Number 21. A computer can't look at all inputs at the same time. Now, this is basically the automotive computers. I'm sure this is not true anymore because you've got hyper-threading, you've got multiple core processors and all that. My phone's got two processors and two cores in the processor. But it says a computer can't look at all cores at its input at the same time. Got to examine them based on a program priority rating, and that's called sequential sampling. Number 22. If a crystal is doped with arsenic, antimony, or phosphorus, this material will have free electrons and become negatively charged, and this is referred to as N-type material. N-type material. All right. Number 23, if a diode is hooked up with the wrong polarity to its two ends, it is reverse biased, and there will be no current flow through it. All right, look at this, just very briefly. A diode, if you see it, is going to usually be black with a white stripe. Got it? Everybody see that? This is important. Everybody look. See it? It's going to be black with a white stripe. The symbol that you see on your schematic is going to be an arrow with a block. And that's the way that goes. Right?
What was number 23?
Huh? 23 is actually reverse bias. Reverse bias. If I hook it up so B plus is here and B minus is here, in other words, if the B minus part of the circuit is here and B plus is here, nothing's going to happen if it has to all flow through this diode. Because current cannot go backwards through that diode. A diode is a one-way check valve for electricity. There's a bunch of them in an alternator. Okay, but if I type B plus here and B minus stuff over there, it's going to go sailing right on through. See, that's why this block is here. Boom, boom, boom. Can't go through there. This is what it looks like in the real world. That's what it looks like on a schematic. I'm just trying to give you a little bit of something to, when you see it, I want you to be able to say, that's a diode. I taught my son Matt this stuff. He would buy these little phones that you build that have like a handful of resistors and transistors and all that crap and a little instruction sheet. And he'd get out there in my shop, my workbench, and he'd put a soldering iron on, and he'd solder every doggone one of that stuff on. He'd build him a telephone that you could plug in and talk to somebody else. Well, see, after he did all that stuff, and I taught him about all of the electronic stuff, that's why he made as high as he did on the ASVAB test and wound up in the nuclear program. See what I mean? Just understanding that stuff, it puts him so far ahead of everybody that never was taught that, you see. I was kind of weird. I taught my kids stuff that most people don't teach their kids. Of course, around here it's a little different than it was in Georgia over there where they were. Luke said he was the only boy in his class that could drive a nail or use a skill saw when he was 14. But I mean, just about everybody in this part of the country can use a skill saw to drive a nail. You know, up for 10 years old or older, you know. Yeah. Number 24. We're almost done. Vehicle manufacturers use blank systems. What? Multiplexing, okay? Okay, a blank module, which allows data exchange between the different buses, is used for all three CAN bus networks, CAN B, C, and diagnostic CAN C connect together. Now, these are different speed networks that do different jobs. That's called a central gateway, basically, a CGW. That's what that is. All right.
So it was 25?
Huh?
That's the gateway.
That's 25, central gateway.
What was 18?
Somebody tell him what 18 is.
Breakout box.
You can shorten that to Bob. Okay, you got that?
Do we keep this